What's up guys, Cwesolo here, and today we are back for another video on how to code in C#. Last time around we covered abstract classes, how they work, a little bit of inheritance, and this time around we're going to be covering inheritance a little bit more deeply, and to kind of give you the gist of it and how it kind of works. I do want to apologize for the lack of uploads recently. I'm back in college now, as you can see from the different environment around me. It's not my bedroom anymore, it's my dorm. So yeah, and also I was sick for a week and I've been busy with homework and stuff, so I'm gonna try to keep a weekly upload schedule and try to work on a video to get one up once a week. Hopefully I can keep on that with tests and stuff like that going on. And I've tried recording this video like 3 times now and it didn't go the way that I wanted it to, and then this is like the 4th time that I'm trying to record this now, and the last time I forgot to make sure that my mic was registering in the software and it wasn't, so oops. Anyway, yeah, so for just me having to record this video 3 times or 4 times over, can you hit that subscribe button down below and hit that bell icon right next to there? Just subscribe for weekly videos and more game dev content. That'd be very cool if you could do that. And let's get into this. So, all right, we're back in Visual Studio here, and we have our shape class. I made some changes since the last video. I added a couple things. I added a perimeter abstract method. I made these protected doubles instead of integers, and that is pretty much, I think, all the changes that I made. This class should be relatively familiar if you watched the last video. If you missed out on that last video, there'll be a card in the top right corner of the screen, so that way you can go check that out. And that way you can see what you missed out on. Yeah, so we went through this abstract class in the last video. Do note that abstract classes can only hold abstract methods, so these you can't put an abstract method in a non-abstract class. These must go in an abstract class if you want to use abstract methods. And note that these must be overridden in all children classes that are directly inheriting from the shape class or whatever abstract class we were using, right? So we're going to go ahead and hop into our circle class. This is not an internal class. I was screwing around with some stuff, and that's not supposed to be an internal class. That is supposed to be just a normal class. Oops. I'll probably end up doing a video on internal classes later at some point. I'm not quite I've never used an internal class before. I'm not quite fully informed on the topic yet, so we'll save that for another video. Programming languages do have a lot of features in them that a lot of times go unused, so just know that, yeah, you may learn a programming language, but you might not learn everything about it. So, and there are a lot of things that are in these languages that you may never use in your entire career of actually using the language. So, but in my experience with C#, I've never had to use an internal class. But I'm sure they are useful, and that's not today's video. So we'll be covering that another day. Anyway, so we have our circle class, and it is inheriting from shape, and the area is, we have the area and perimeter here. As you can see, these are the overrides for our abstract methods over here. Nothing crazy here, so that's pretty much the circle class, nothing crazy. As you can see here, we have multiple classes inheriting from the same abstract class, just to kind of show that you can have many classes inheriting from the same parent class. I'm going to use a parent-child relationship in terms of describing the relationship between inherited classes. So the shape class here is the parent class, and circle and rectangle are the children classes. So, and as you can see, the rectangle class also uses some of these overrides, the abstract methods that are here in the shape class. We do have a square class, so I changed the square class, and square class now actually inherits from the rectangle class. So we have the square class that is at the bottom of the tree here, and then we have, I'm going to go ahead and swap to this view. So we have the shape class on the bottom, and then we have the rectangle class that is above that is the parent of the square class. So you have the rectangle class being the parent class of the square class, and then you have the shape class being the parent of the rectangle class. So you have the grandparent class of square being the shape class. And you can kind of go down, like you can have classes inheriting, you could have 10 different classes all inheriting from, each other. So you could have one class and then inherits from another one. Then you have another one inheriting from the one above that. And you can have a chain of them, and you can still access all the data from those classes. And I'll clearly show this right here after I get rid of those two things. So as you can see here in the square class, we have the public overrides used for set width and set height. And those methods are both used here. So here is set height, and here is set width, just right here. And those are both being able to be used and changed and modified and overridden in the square class, despite being a child of the rectangle class. So this is actually something that's very cool with inheritance, is the fact that no matter how far down the chain you are, as long as you're inheriting from a class that is connected from a class that is above it, you get access to all the things that are at the class that is at the very top of the chain, right? So I guess you can call it the base class, right? The base class is able to be, the methods in that base class are able to be accessed by any subclasses that are below that. No matter how far down, no matter how many subclasses you are down the chain, you are able to access that same base class. That's another word for a parent class, but the shape class is the grandparent class of the square class. And the square class can access any of the methods that are used in the shape class and rectangle class too. So if I were to say add more overrides, or not overrides, if I were to add more virtual methods into the rectangle class, you would be able to access and override those within the square class. There's no need to do that here because, well, this already covers the area and perimeter, and all that the square class needed to do was just modify the set width and set height. But obviously, if you're working on an actual project, this would get more complicated than just this, obviously. So as you can see here, we have set width and set height that are all overrides of the methods here. So this is actually very cool that we can access those things from the shape class, directly from the square class. And if square class had any children that were below it, any classes that are child classes of it, it would still have access to the shape class as well. Do note that in C# there is not, I just want to make this very apparent, there is no such thing as multiple inheritance. You may have heard of multiple inheritance. It's basically the concept that a class can inherit from multiple other classes. This is not possible in C#. There are ways to kind of get around that using interfaces, but you can't actually do multiple inheritance here in C#. You can only inherit from one class at a time, similar to how Java does it. You can only do one class at a time. Now, a language like C++, you can inherit from multiple classes, or other languages can do that as well, but not C#. C#, that's not a thing. If you want to inherit from quote-unquote multiple classes, they all need to be linked together in this kind of inheritance chain, right? In the case here with square, it is not only inheriting from rectangle, but it's also inheriting from shape, because rectangle inherits from shape and the square inherits from rectangle. In that case, you can kind of say, hey, it's inheriting from multiple classes, but it's an inheritance chain. It's not actually directly inheriting from two different classes. And even if I were to try to inherit from, say, circle here, you wouldn't be able to do it because, well, the square class cannot have multiple base classes, right? It can only inherit from one class, one base class, that being the rectangle class, and that inherits from the shape class. I also want to kind of go over naming, okay? Because there is different names for the inheritance structure, and you may hear these names elsewhere. So I've been going with the child class, parent class thing here, right? And I think that's probably the easiest way for newcomers to understand it, as the rectangle class is a parent of the square class, and the shape class is a parent of the rectangle class. But there are different names for it. So, for example, square class here is a subclass, and rectangle is the superclass, and shape class is the super class. that's another way of going and talking about it. And the rectangle class is a subclass of the shape class, and the square class is a subclass of the shape class. You could also call square class a base class, or the subclass of the base class rectangle. So rectangle is the base class of square, and the shape class is the base class of rectangle. Those are the different kind of names. They're all kind of there, depending on which videos you watch, or whatever you want to call them. You can call them a parent class, a base class, or a super class, whichever you prefer, whatever nomenclature you prefer, that's what you can go by. But just know that they are all the same thing, and when someone talks about a base class or a super class, it's the same thing as a parent class. Those words are all equal in terms of terminology, and they all mean the same thing. You're referring to a class that is inheriting from another class, right? So, yeah. As you can see here, we're going to go ahead and go over to our main method here, and as you can see, we have some circles. So I made a circle, and it is going to use the area and perimeter method overrides from the shape class. Down here, we are getting set height. We are using making a rectangle and setting the height and the width. I realized that we made a slight mistake here. And I have to fix that. Mild mistake. As you can see here, we're setting the height and the width, and here we are the square. We're making a square, and it is setting the width. But since the square has all equal sides in the square class, it just sets the height and the width exactly the same. And then if this method is called, it just calls set width and passes the height in. So, yeah, that's pretty much that. If we run this, as you can see, we'll get all of that data, and it all works. So as you can see, the square is able to get the perimeter and the area directly from the rectangle class, and it also is able to set the height and stuff by overriding the methods in the shape class, which is pretty cool. I think that's pretty much it for this video. It's been going on for like 12 minutes, so yeah, I think that's all I really wanted to cover. I don't think there's really anything else to talk about. But that's pretty much how inheritance works. It's very cool. It's very useful. Actually, recently I was helping someone out work on their game, and they were trying to create a way to have different abilities that all have access to the same methods and same base data. And I helped them by creating an inheritance structure for them. So that way they were using an abstract class, and they were inheriting from that, and they were able to have multiple abilities all inheriting from the same class. It really helped them out, and this is something that is very useful in not only game development but for programming in general. So I do suggest that you may want to learn this feature and get used to using it. It is very important to know how inheritance works. It's very useful. So yeah, if you like this video, leave a like, comment if you have anything to say, any questions. I'll try my best to answer them, and do subscribe if you do like this kind of content and you want to learn more how to create video games, or you want to learn more on how to code, or any kind of computer science stuff that I may be covering in the future. Yeah. Also, go wishlist The Amazing Ball on Steam. I'll have a link in the description, and you can go check that out and wishlist it. That's my game that I'm making. I've been making it for 4 years, so it's 4 years in the making. So you should go wishlist that. That would be really awesome if you could do that. And yeah, I'll see you guys in the next video. Hope you have a great day, and peace out.